Very honored to be speaking at SQL Bits for the first time, albeit virtually. Maybe next year I'll be able to make it in person. So what I want to do is in the next 20 minutes here, talk through what is a data engineer and some of the skills for success. So just so you have my information, if there's more information you want to see, kind of tutorials, live demos of what I talk about today, go to youtube.com/Dustin Vanway, and you'll see a bunch of content I've got, including I'm working on a Synapse series right now that kind of goes hand in hand with some of the technology I'll talk about, but I won't have time to show in this session. So I'm a data and AI consultant. So I work in a variety of organizations on a lot of different projects, usually focused on Azure though. And I have a data engineering San Diego meetup group that meets virtually. So I'm going to invite you to join me in that. You can find it on meetup.com or connect with me on LinkedIn to get connected with that, see upcoming events, and also to ask questions because we won't have a lot of time for questions, probably no time for questions in this session, but I'm available via LinkedIn, okay? So please leave feedback, very valuable for us. And there's some benefits. You know, every 10 you do, I think, plants a tree. So please do that for me at the end. I'll show this at the end as well for you. And then we're going to talk about three main things today: responsibilities of a data engineer, which will be fairly short; skills of a data engineer, which is kind of broadly outside of Azure, anywhere you're working, skills of a data engineer. And then we'll get into Azure Data Platform architecture and some of the core services that I think are important for data engineering. Now, I thought I was signing up for a 20-hour session, not a 20-minute one. So you have to hang with me, but we'll have plenty of good discussion, and then you can follow up on YouTube and catch some of the other amazing SQL Bit sessions for more info. One of the questions I get quite a bit is, what the heck is a data engineer? At my meetup, it's something that comes up a lot. So here's like my really quick breakdown. So we need data to make decisions. We probably know that. That's probably why we're at this conference. And we know that data is everywhere. It's both internal, it's growing all the time internally, how much we store. It's also growing externally, public data, third-party APIs we can use. So in order to analyze, in order to make decisions, in order to get value out of it, someone has to collect it for us. And so you may know this if you've been working with data a while, but if you're new, you also really need to clean it and transform it and manage it, or you're not going to get the value you expect. And so who can do all of this and more? Well, that's where your data engineer comes in. That's their main kind of focus. And so I've replaced my normal superhero with Mario the plumber for the theme today. And the plumber is a good one because data engineers are building data pipelines that allow data to flow from one place to another smoothly, connecting all that stuff. And they don't always get a lot of notice and credit. Not everyone understands what they're doing, but if they don't do their job well, if what they built isn't working, people notice, right? So let's go deeper by talking about the responsibilities of a data engineer. So one of the main responsibilities is collecting and organizing data, not just moving data around, but collecting and organizing it in a way that's going to be usable and discoverable by end users, which is a lot of times data scientists and analysts. Sometimes it's business users themselves that connect to your data. Now, just collecting and organizing isn't enough. We need to transform and clean that data. And this can be the bulk of the work depending on where your data is coming from, how messy it is, how much transformation is needed to make it valuable. But transforming and cleaning is a key piece of data engineering. You may or may not already know this, but data engineers, even if they don't tell you this, are responsible for securing the data. There's decisions you make as you load data into databases. There's decisions you make if you're scripting out the resources you'll use about where do we do encryption, which data is highly sensitive and needs extra measures to be secure, who gets access to the data, how do we organize it in a way that security can be applied. So don't forget this, even if they don't say it out loud, you need to make sure data is being secured. And maybe you have a specialist at your organization that can help you. That's great, but don't forget to ask those questions and be a part of that process, okay? So supporting data science and analytics, when I was working not as an official consultant, I was working internally on a team of data engineers. We found ourselves being consultants just to other people within the same company to teach them the new technologies we brought in to work with the larger data sets or the modern data stack that we had. We were teaching them things like SQL and how to query the data more efficiently. We're kind of monitoring what they do as well and helping there. This can also mean, though, it can mean taking code that's been written in maybe R or Python to do machine learning or some type of AI processing. And that code may need some more things done before it's ready for production. Sometimes it's a full rewrite. Sometimes it's just adding logging, making it apply to a framework that's manageable. So sometimes this is a very small part of the role, but it's almost always something that someone on the team needs to be ready to support others and make sure that You're not just building things and throwing it out there. You need to be able to support them and help them get onboarded to your systems. Speaking of systems, so data platform is something that could be the sole focus of a data engineer. Usually, if that's the only thing they do, that gets called something like a software developer with some kind of special data word thrown on the end. But data platform can be a really big part of what a data engineer does. Or at a minimum, if you're focused on these other things I've talked about more so, you still probably have some reusable tools that you're trying to build and work on. What you're really trying to do is empower others in the organization to do the kinds of things that data engineers would have to do otherwise. So look for reusability, not just within the data engineering team, but tools that can help others be successful. So this is our rundown of responsibilities. If you think I missed something important, by all means, message me. I love to hear feedback. And if we had more time, we could sit and discuss a little longer, of course. So 6 minutes in, it looks like, and we're at data engineer skills. So we're to the skills. Remember, this is going to be a little broad at first, and this is my biased opinion based on where I've worked and what I've seen, okay? So Python or Scala or some other programming language that will help you move data and do the things we just talked about, I think is maybe not essential for every single data engineer. You can get the job without this sometimes, but it's going to be expected at some point that you can connect to APIs and do some types of processing of files or data that isn't built into the tools that you can get that make it no code or low code for you. So I highly recommend, if you are trying to do data engineering and don't know any programming languages very well yet, that you do some practice of this and look for ways that it could make your job easier. That being said, SQL is still important. Few reasons for this, though. One is a lot of the database systems, even if they're new modern systems, speak SQL well. In Azure, most things that we're going to use do work with SQL pretty well. Some of them only work with SQL. But even if you're working in technologies like Spark exclusively, which can use SQL but doesn't have to, it speaks SQL pretty well. When you connect to it from Power BI or Tableau, you're probably writing SQL there. And even if that's not the case for you, you're going to inherit some sort of project that's thousands of lines of stored procedures that needs to be rewritten in the new system you're building. So be prepared to read and write some SQL. Spark, Hadoop, really any kind of distributed system, big data platform that's meant to run on a cluster of machines is a skill that may not be required everywhere, but it's very common for data engineers to work with these a lot. So I do a lot of Spark development. So I'm a little biased that that's an important one to learn. There's a lot of competitors, but the main idea is something that is going to allow you to add more nodes, scale out how many nodes you have, scale those nodes up and down in order to do processing of data in parallel or concurrently, to be more precise there. So along with that, there's these cloud analytics services, super broad term, but the idea is that depending on which cloud you're using, whether it's Azure or one of the competitors, you're going to have specific things that are services within the cloud. They're managed for you. They're usually easy to spin up the first time. And you need to kind of know how that compares to vendor tools that you could put in the cloud or other open source tools that might be out there. And so make sure you do a little bit of research. I recommend getting hands-on or at least watching tutorials, which is why I do so many demos on YouTube. Like, make sure you get to see what this thing looks like, get a feel for the developer experience so that when the conversation happens, do we go with this technology you like that's open source or by some vendor, or do we go with the cloud analytics service version of that our vendor tells us, our cloud provider tells us is amazing? You can have those conversations and you don't get caught off guard and make the wrong decision. Now, don't forget software best practices. And they don't apply exactly the same way to data engineering as they do to software development all the time. But there's a lot of things that software development has figured out about how to build things to last, how to build things that are manageable and maintainable for a team of people. And at some point, even if you start off as a solo data engineer, other people will need to get involved and help maintain the thing. So do look into software best practices like automated testing, continuous integration, and so on. You may not need as much of the patterns, though. The more you know about this, the more you can talk to other software developers as you do in your work. Gives you more street cred, gives you more respectability, I guess, as you have conversations with teams that you'll likely end up working with.
Dustin, you have
Okay,
10 minutes. You should be halfway.
so so there's our top data engineer skills. And you're probably thinking, hey, you missed my favorite one. So here you go. If I missed your favorite one, maybe it's on this list. If not, by all means, send me that email, send me that LinkedIn message. So we won't go deep into these because I'm going to talk about the ones I think are most important as we talk about the services next. So here we are, data platform architecture. I have two views for you of a pretty simple simplified ingestion architecture for data engineering. Okay, this is going to be looking at things that work really well within Azure and come within Azure. So on the left side, this could be anywhere really as the sources. You've got your web application and services that are going to be producing data, likely to something like event hubs for you on the bottom there. And then you have internal databases, maybe you have third-party APIs and cloud systems that you connect to. And so what we're doing is the top level where we go to Azure Data Factory is more of our batch-oriented data pipelines. And so we have something scheduled through Data Factory, maybe once a day, maybe once every couple hours. And that's going to be a job that kicks off a bunch of different Spark code that does the actual processing and cleaning and transforming and enriching. And that would run on something like Azure Databricks and do some heavy lifting, do some heavy transformation, write that out to data lake storage, and probably either within the same job or a follow-up job that's all orchestrated through Data Factory. It would do additional steps to make that data ready for like your production reports. And so you can do a lot more at Data Factory, which we'll talk about, but think of it in this picture as our orchestrator of everything. Event hubs then on the bottom is for our real-time streams of data. And you don't necessarily need to process it in real time. Event hub stores that data for you so you can have some time to run in batch if you choose to. But things that need to produce data to you and don't really want to worry about what's going on your end can send it through event hubs message by message, and then you can process it as quickly as you choose to. And you still could use Spark streaming within Azure Databricks to do that pretty well. And Azure Data Lake Storage is going to be fundamentally, when we're talking about ingesting and building data lakes or lake houses, those types of things, data lake storage is a core piece of that. That's where your data lake exists. And there's a lot more we could talk about data lake storage, but it's kind of nuanced and not really the focus of this session. These other technologies we'll talk about a little more though. So let's just replace some things in that picture with Synapse instead. Same concept. Synapse Pipelines replaces Data Factory, does exactly what I just described for batch oriented along the top row. And then we could use Synapse Spark pools for what we would do with Databricks. Certainly some differences. Developer experience is different. The way you set it up is a bit different, but all in all, you're writing Spark code. You can pretty easily move code between those two systems as well. So then if you're doing streaming, we still have Event Hub. That's still a piece of the puzzle. If you're not familiar with Event Hub yet, but you know Apache Kafka, just think Apache Kafka. Think of us using it the same way. And then from there, we have this option of stream analytics, which lets us do SQL in order to do stream processing. And that's kind of an Azure native way to run this serverlessly. That works really well. You can do some streaming with Synapse Spark. I don't know how common that is. It's a little bit different just to keep it running and know what's going on, in my opinion, than with working with Azure Databricks, but it's certainly a possibility. And again, Azure Data Lake Storage serves as the foundation of where we store our data in our data lake. So now to Synapse pipelines, which what I didn't talk about too much yet is that you can do low code ETL there. And there's tons of examples of Azure Data Factory and Synapse pipelines. I think of them pretty synonymously now. If you're getting into SSIS world, definitely look into the differences of which one has what you need and generally available. But otherwise, what I do is I use it for orchestration to set up Spark code, other custom code, maybe some SQL scripts that are going to do the real processing. And that's just the way I approach data engineering in most cases. I find it easier to do source control, to manage changes and things if I'm writing the code instead of using the Data Factory UI for everything. But it can build serverless data pipelines. You can do mapping data flows and run Spark under the covers without even really realizing it's running Spark. You can set up scheduling alerting really well with this and do auto scalability. Now to Azure Databricks, let's spend just a little bit of time on that one. So they describe themselves as a unified analytics platform. It's a good name. I like it. So what they do as a data engineer, what they provide that's really nice is they manage Apache Spark for you, but they also apply a bunch of things, some of which you're going to end up with anyway, from my experience, when if you're using Apache Spark, like notebooks, you're probably gonna have a notebook solution. Scheduling, you'll need some sort of scheduler. You could use the Databricks one, which is getting really more and more sophisticated each month here. But it also has a bunch of machine learning tools. It has some newer capabilities for how you connect to that database. And along with the way you can use these SQL endpoints to connect and run SQL code from Power BI, for instance, they have performance optimizations, including like their own Photon engine. The pricing's a little different, but they've optimized how it works with Apache Spark, especially within this Azure Databricks environment, working with Azure Data Lake Storage. It also has really good auto scale and auto terminate capabilities, Most things I'll talk about have that these days, but they've been doing that really well for a while. And so you're not always paying for the machine to be on. Depending on your use case, how much people are going to report live off of that data, you may not need to pay to have things always running. And even if you do, those things can scale up and down based on some thresholds that you set.
You got 5 minutes, Dustin. 5 minutes.
Azure Synapse Analytics is a big one here. So instead of unified, I call it integrated analytics services. The offering is different, but it's a lot of stuff baked into one. And so managed Apache Spark is also available via Spark pools. And there's a lot more that we could say about that. We'll cover a little bit about when to use what in just a second here. So serverless SQL is a way to query that data from your data lake very easily on demand. Whereas dedicated SQL is a way to load it up, think about the modeling, think about how you're going to distribute that data and get faster read performance at a higher cost. Azure Data Explorer is in preview, but that's really built for ingesting a lot of log data that's not going to change, or ingesting time series data and doing analytics on top of it. And then we have autoscale and serverless capabilities built in. Of course, you should have that by now, but we don't always have it. So I keep it on my list for you. So now here's kind of my breakdown of the capabilities. For serverless Apache Spark within Synapse, I like to use that for data processing and for expiration. So I write most of the ETL data pipeline code I write these days, I write with Apache Spark. Now, serverless SQL then is how a lot of people would connect and query the data, whether or not they have a question that they need answered, or they're doing some kind of extraction for a report or setting up a file feed. Serverless SQL is a way for them to write T-SQL and get that data out and just pay per terabyte used, basically. Dedicated SQL is our massive parallel processing database for high performance analytic queries. An alternative, though, if you definitely look at the pricing, if you do this, the smallest pools don't get you as far as you might want. Look at the pricing if you're going to go this path, figure out how to distribute that data in order to make sure you do it well. But also think about maybe Azure SQL hyperscale as an alternative if the pricing for dedicated SQL compared to your data size just isn't a fit. And then Synapse pipelines, I think we've covered enough, hopefully. So you can find more about that later if you need. Let's talk about event hubs here. So I talked about it being this where the data gets produced and where it gets consumed. It's kind of this middle layer, this broker that lets us produce as much data as we want. The other side can consume it without really having to know much about each other. It's Kafka compatible. You can use the Kafka protocols with it, which I think is really powerful and allows me to reuse a lot of code libraries I built in the past. And then we can auto scale and set things up at the namespace level. So take that one step further. If I have a feed of data called trip data and a feed of data called vendor data, those will both feed into event hubs from the producer with a certain schema. And then my consumers really don't know much about the producer and vice versa. And they don't know anything about each other. And we have about 1 to 7 days of history on event hubs. So while we would probably consume fairly real time, at least within an hour, we can also replay the last day or 7 days, depending on our history settings, if we make a mistake or we just have reasons to go reprocess and clean things up every night. Stream analytics, then I talked about, is a T-SQL or a standard SQL language on top of a stream processing. So you connect it usually to event hubs, pull that data in. It's fully managed within Azure, really easy to click some buttons and get it set up. The SQL language will be easy for you to pick up if you've been writing SQL in any form. And it gives you
Left,
exactly
Dustin.
one's processing
1 minute.
and scales easily. This one's very helpful for, or it's required for the certification test. So definitely get hands-on if you're going to get certified. I don't see it used as much on the projects I work on. So it might be one you kind of pick up a little later in your data engineering journey, but certainly it's good to know about because it's an easy way to get stream processing set up. Setting up Spark streaming off of event hubs is a lot more complex, though it is super powerful. And that's what I tend to do because I'm already working in Spark for the rest of my data pipeline. So the final thoughts for you is that you can do this. If you're new to data engineering, if you're new to Azure, you can do it. There's tons of resources out there on YouTube through these, the community is providing at conferences such as this one. So please be confident you can dig in and learn what you need to learn, and keep an eye on your local job market if you're trying to figure out how to be marketable within your region to see what's most commonly used there, and start there is my recommendation. Please reach out with any feedback or thoughts to me directly via LinkedIn. And please leave your official feedback for SQL Bits via this URL or scan that little code. And that's the end of our session today. I thank you so much for joining me here and hope you got a lot out of it. I look forward to hearing from you in the future. See you next time.
Well done, Dustin. Really good, man. Thank you.
All right. Thank you so much. I'll sign off then.